Take a moment and ponder how you might draw an antibonding orbital on this enamine. If your MOMADAC topic is an electrophile, you'll definitely want to think about how to draw antibonding orbitals. You'll quickly realize that this is a rather complicated proposition because we need to draw 4 lobes rather than 2 in the case of antibonding orbitals. We can draw the 2 larger lobes fairly easily using LCAO cartoon. But then we need to draw 2 more central lobes to illustrate the node between the nuclei. As you might imagine, drawing a lot of antibonding orbitals becomes a tedious process because you need to apply 4 LCAO cartoon commands every time you want to draw an antibonding orbital. To help you get started with the process of building antibonding orbitals and other kinds of orbitals in JMOL, we've developed a tool called the Orbital Creator. This is part of the butane JMOL repository, and after uploading a JMOL to butane, you can explore it using this tool as well as the others. What you're looking at here is a single amide within a long polypeptide chain. You can build an orbital between 2 adjacent atoms by clicking on each of the 2 boxes and then selecting an atom in the JMOL window. You'll see its atom number appear once it's been selected. Then choose an orbital type. In this case, let's choose a sigma star, and then click Show Orbital to display the orbital in the window and make the atoms transparent. Notice below that JMOL scripting code is provided for you. And notice that rather than using LCAO cartoon, the Orbital Creator uses the isosurface lobe command. Isosurface lobe allows you to draw lobes of orbitals with a high degree of control. To apply this same orbital later, just copy this code and paste it into the console whenever you need to use it. In fact, the code is even transferable across different models as long as you make sure to change the atom numbers depending on the situation. You should also think about the effect of scaling the orbital lobes. The Orbital Creator will give you orbitals that are symmetric, but as we've learned, the size of the antibonding orbital of a carbonyl on carbon is not the same as the size on oxygen. Think about and explore how you might change these numbers to increase the size of one lobe or the other. Once you become adept at creating orbitals, you can simply explore using the console itself, the isosurface lobe commands, and LCAO cartoon. Finally, I wanted to show you a quick trick for showing localized molecular orbitals if you have a .mo file handy. You can combine the mo command with the isosurface command in order to selectively show a molecular orbital only on selected atoms. For instance, if we only wanted to show the HOMO on the carbons of the enamine, all we would have to do is select the carbons and then apply the isosurface mo command in order to selectively show the HOMO only on the carbons. And there you have it. Using isosurface mo, you lose the information about the orbital in the upper left-hand corner, but you gain the ability to selectively show parts of the molecular orbital.